Hello, everyone. Hi, welcome. I'm David Habusha. I'm the VP of Product with WhiteSource. We help companies develop better software by harnessing the power of open source. Just a quick question before we start. How many of you are developers here in the audience? Wow. How many of you are with DevOps teams? Security teams? That's it. Oh, wow. Okay. Now, those of you who answered that you are a developer, how many of you like resolving security issues in your code? Raise your hands, come on. Typical answer. And this is exactly the topic of this presentation. I'm going to talk about how you can secure your open source components by using the existing workflows in GitHub, and now you can prioritize security vulnerabilities remediation. As a background, and this is something that we all know, open source comprises more than 80% of any modern application. If you have 100,000 lines of code in your app, more than 80,000 lines of code will be comprised of open source components from third-party sources that you don't know what's in there. We at WhiteSource generate an annual report with regards to security vulnerabilities in open source components. And the trend that we're seeing in the last 18 months is that the number of reported security vulnerabilities in open source component grew by more than 50% year over year from 2016 to 2017. If we look at the 3 quarters of 2018, this trend just keeps on. So you can expect hackers to try and hack into open source components running your applications. Not only that, if you look at the deviation between the open source projects and the number of security vulnerabilities associated with these projects, you will find that the risk is even larger when you use the popular projects, meaning that they are the center of modern attacks. I'm sure that's not surprising. While doing that, we see that dev teams, security teams, and DevOps teams invest a lot of time, money, and effort into resolving security issues in open source components. But the flip side of it is that there's no actually a single process or something that most companies do to resolve these open source issues. And in the same survey, we asked these companies, how do you usually resolve open source security issues? As you can see, there was no single answer. So I'm sure that you're all aware of the way security vulnerabilities are handled today. Usually you will find the security teams monitoring your systems, assessing your code for security issues using various tools. They will send you as a developer a list of probably the high severity vulnerabilities over email, an Excel sheet, or some kind of a Jira workflow or other trouble ticketing system. And then you'll need to start reading these long lists of security issues and resolve them in your code, which is, as you said, it's not something you like to do anyway. So that's pretty much not the way to handle security vulnerabilities in the modern world. And as you can see here, and based on the answers I received in the beginning of this session, there is a big friction between the security teams and the development teams, having the DevOps teams in the middle. Although we see trends such as DevSecOps starting to rise, there's still a big friction because I'm sure that you, as developers, you like to write cool code, you like to run the latest technologies, but really resolving security issues is not something you like doing. It doesn't have to be this way. So the essence of this talk is how you can actually do that in a very little time, and you don't have to leave your ongoing day-to-day working environment. You can do that within GitHub, and I'll show you how. To do that, you have to make sure that you follow the essential components that will drive a correct security vulnerabilities remediation process. First of all, you have to understand what open source components you have in your pieces of software, including all the dependent packages and transitively dependent packages, because they may be vulnerable as well. You have to have a solution in place that can scan any programming languages used by your software, any package manager, any source file that is taken from the open source community. All of these needs to be scanned to be able to provide you with the full picture of the security risk associated with your open source components. And you need to do it continuously. It's not enough to scan one time, because open source vulnerabilities keep on coming and they may affect your existing software. You need to make sure that developers like yourselves are empowered and can receive the right alerts and the right tools to actually handle open source security issues. First of all, when you choose the open source component, you need to make sure that the component is safe. After you chose the component and you start developing using the component and you start pushing code to your development branches, you need to scan this code. You need to make sure that you didn't introduce any new security vulnerability to your code. Then when you generate a pull request and you merge it into your master branch, you also need to make sure that all the project is being scanned again for security vulnerabilities. And lastly, you have to make sure that new vulnerabilities generate alerts based on your open source components, and will give you the right set of information to actually understand the originating source of the alert. So if you want to bake security into your existing workflows and you want to do it effectively, you have to make sure that you address these two things. One, prioritize only the right vulnerabilities. Focus your time on only what matters, and we'll talk about that. And second, you don't have to leave your IDE and your GitHub interface. You don't have to go to other tools. You don't have to read Excel sheets or emails. You can do all that within GitHub. So let's talk about prioritization. A quick question here, again, audience. When you have an open source component like Apache Struts or Spring, and the new vulnerability comes up, any idea how many of these vulnerabilities are actually being called by your own proprietary code? Meaning, do I really reference the vulnerable lines of code or the vulnerable functions? Anybody thinks that these references may be something like 50%, 60%, 70%? No idea. Okay, 80. Good answer. So if you look at it, the fact that I'm using a certain open source component and a new vulnerability comes up, or a set of vulnerabilities affecting the specific version that I'm using, doesn't necessarily mean that the code that I wrote is actually affected by this vulnerability. And if you look at it, you can reduce the load on your development teams by a significant measure by only focusing on the ones that are reachable from your proprietary code. And this is the modern way to prioritize security vulnerabilities in open source components. So back to my question, this is pretty much the number, although we launched a similar technology in WhiteSource, and from running beta tests on dozens of customers, we found that this number is even higher. It's more than 80% of the vulnerabilities that are not really effective. And when we see customers installing our product, running them on modern applications with probably hundreds of thousands or millions of lines of code, usually they'll end up with dozens or hundreds of security vulnerabilities associated with it. And they just don't know where to start. It's such a headache that they need to start prioritizing and speak to the development teams and ask them to fix the vulnerabilities that matter. But the truth that matters is that they don't really know where to start, and usually they do nothing because of the huge load of the security vulnerabilities. So how do you prioritize? So you first need to understand and report the vulnerabilities that actually can be referenced from within your proprietary code and referencing the open source vulnerable lines of code or functions. And not only that, when you have these types of technologies in place, you can also send the full evidence to the development teams. You can send them the line of code that caused the vulnerable code in the open source. You can send them the full stack trace. So in terms of remediating it, you don't just send them name of a library and a CVE or a vulnerability attached to it. You just give them everything they need to actually resolve the issue. And that's the modern way to handle security vulnerabilities. If we look at an example here, using OpenSSL engine, Java code, OpenSSL engine in the version used by this example is actually referencing vulnerable code in an open source component. And you can actually get a report showing you how this CVE is actually could be exploited by hackers, and how your application is actually reaching these vulnerable lines of code. You can send that to developers. They can comment out the code, they can bypass the code, they can upgrade the version of the software component. There's many different remediation options that could be applied when using effective usage analysis technologies. And if you look at what happens if I comment out the code, I use a different type of OpenSSL engine or any other remediation advice, I can clean the system and actually see that I'm not referencing the vulnerable code now. So the key to prioritization is focus on what matters, focus on the vulnerabilities that really matter, the vulnerabilities that may actually be exploited in your app to hack into your system. What I'm going to describe now is the normal GitHub workflow. There's nothing actually different or changed from your normal day-to-day, the way you actually interact with other developers, the way you build applications. But I'm just going to show you how you can bake all these security checks into the existing workflow without leaving GitHub. So normal workflow starts with commits on developer branches, any number of commits. When any developer is pushing the code to the developer branch, that's the first step to start scanning for security vulnerabilities. Very early in the process. You don't need to wait for the runtime, you don't need to wait for the build, you don't need to wait for the pull request to merge to the master bench. You can already discover most of the issues in the first push to the development branch, and you can fix it early in the process and make sure that a lot of time and cost is being saved by doing so. GitHub provides something called webhooks. Webhooks, you basically subscribe to various events in GitHub. Push is one of them, and you can get a payload from GitHub with all the details necessary on the push webhook to actually start and initiate a security scan. GitHub announced recently something called the Checks API. Checks APIs allow you to, as developers, to run checks before things actually happen in the code. With regards to push, these checks happen asynchronously. They don't stop push, but they can run these checks and they can report on the success or failure of these checks, but you can also do other things with that. So whenever you trigger a check on a push, the check is being transferred into something called a queued state because it's asynchronous. You can run a security scan by launching any tool that is capable of running these security scans, moving the check to the in-progress state, and then you can report if there's a security vulnerabilities using GitHub issues. So you can do the whole workflow from within GitHub, and I'm going to demonstrate how you do that. When you decided that your code in your development branch is is ready to be merged into the master branch and being built as a full application, you start running pull requests. And when you do a pull request, you want to merge your code into the master branch and start building the app. That's the second place where you need to run the security test. And in this case, using a push webhook and the checks API, you can actually fail builds. You can stop the merge and run a security test. And if the security test failed, you can report multiple different statuses. You can annotate lines of code. You can generate a comment with the exact details of the vulnerabilities being found, and you can open GitHub issues. So that's another step of actually maintaining a secured repository. You don't want to allow push requests that generate or add vulnerable components to your application. Now there's various settings in GitHub that actually need to be applied depending on your organizational policies. There's something called branch protection rules, where you can decide if who can actually approve pull requests, and if checks failing pull requests can stop the build or not stop the build. And I'll show you how you do that. So as I mentioned, start with running security assessment on every push in each of the developer's environment, and you can do that automatically. And open issues with the full vulnerability details. The developer will receive an email and will be able to resolve that in the development branch already. Then the second phase is actually running the security assessment on a pull request when you want to merge your code into the master branch. And you can run automatic checks, as I mentioned, using the checks APIs. But it also requires a manual approval, usually by the development team leader or by someone who actually reviews the code. But the manual approval happens after the automatic checks, and the repo admin can actually override the automatic checks even if they failed, although we don't advise you to do so. The checks APIs are available to everyone who actually developed a GitHub app. What they actually announced last year as GitHub apps, they announced the checks APIs together with that, and it's free for everyone. You can use that if you develop a GitHub application. If you don't do that, you have the status APIs, which are less rich in terms of the contents and the statuses, but then you don't have to develop an app. So you can do either status APIs or checks APIs. These are the branch protection rules, and actually I advise you to review that before you start using this process, and make sure that the settings here apply to your organizational policies with regards to how you'd like to merge code into the master branch. And a little bit more on GitHub checks APIs. Again, it's available for GitHub apps. Basically, it's another set of webhooks that you receive. Whenever checks APIs are running and you subscribe to events, you will receive a check suite webhook with action call requested, and then you can basically understand the full payload and what's in there, which request, and what was requested by whom. As I mentioned, you can return rich statuses, not just fail or success, but also annotate lines of code, and you can also kick off reruns. So if something was fixed, then the checks APIs can also kick off a rerun automatically. So you can actually close the loop inside GitHub. And as I mentioned, status APIs are available for those of you who don't want to develop GitHub apps. Let's dive into the anatomy of a pull request. So this is a pull request generated by one of our developers. You see that the checks have started, and they're waiting to be actually assessed by our security testing. We found, in case of a vulnerability being found, you can open security issues. Now, I don't know, how many of you know how GitHub issues work? How many of you use GitHub issues? The answer should have been the same, so hopefully you know how it works and use it at the same time. So GitHub issues are kind of a workflow from within GitHub to actually interact between the teams and resolve issues stemming from anything with regards to making changes in the repository. Now, GitHub issues allow you to attach labels to issues. So you can generate a label called security vulnerability. You can even take it into the level of vulnerability, like low, medium, high severity. GitHub issues can be rich format. There's a markup language that you can use to generate issues. You can generate issue templates, so you don't have to run it all over again. You can add graphics. You can add many things to the GitHub issue. And in that regards, most cases, the developer who actually performed the action will also receive an email with the issue contents right to his inbox. So and they can click on it and open the issue in context, so they don't even have to get an alert from within GitHub to work on the issue. In the issue itself, you can provide all the necessary details, like what is the vulnerable library that generated the CVE, what are the vulnerability details, how you can remediate this issue, and definitely you can add some more metadata like CVSS score, impact, or any other information you'd like to add to your issues. When you start the workflow, the issues are being assigned to the owner of the repo or to a developer, and they can be closed by actually one of the team leaders or the developer the issue was assigned to after actually resolving the issue. And then you can kick off actually a rerun that will close the issue automatically and pass the build. This is how a past check look like using the checks API. As I mentioned in the summary, you can add any information you'd like, but you can see the full life cycle of the check, including the log of the developer who actually ran the check and cleaned it. And in case of a failure, you can provide a rich status, the reason for the fail, and then in the summary, you can add a lot of information why the check has failed. So I'm very excited to announce WhiteSource Bolt for GitHub. We at WhiteSource help the open source community with various tools, and we're launching a free tool today. We're actually announcing it in beta, but you can already sign up, and it's coming in November. This tool actually runs as a GitHub app. All you need to do is just choose the repos to apply it on, and what it will do is it will actually do all this process that I just described. It will scan any push request. It will open GitHub issues. Your developers will receive an email pertaining to the GitHub issue. This tool is actually free, and it complements another tool that we used to charge for, and this is for those of you who use what used to be called Microsoft TFS VSTS, but now called Azure DevOps, and we made it free as well. So then that's available today. So if you're running Azure DevOps, just go and download it for free. It will also run security scans. In this environment, it also generates a bill of materials, and it's free on the Azure Marketplace today. Okay, so a quick summary. We're all using open source. The number of security vulnerabilities associated with open source is growing and will keep on growing, and that's just the reality. What you need to do to actually cope with that and to have the right process in place is to bake in the security into the existing workflows, into the existing tools. As one of my customers told me, and he's running a dev team, we'd like to work with our IDE and GitHub. We don't need anything else, so just make sure that your solution runs there. So that's the right way to do it. And make sure that you actually prioritize the work on security vulnerabilities effectively. You don't need to focus on hundreds of different vulnerabilities. Focus on what really matters so you can make your deadlines, you can work on cool technologies, you can keep on developing code and actually resolve security issues as kind of an ongoing process, and you don't have to, okay, so I have this list again, what do I do with it? I don't want to deal with it today. You can just do it effectively. And you can do that from within GitHub. So just either develop these tools or download our free tool. You can do that seamlessly within GitHub. You don't need to leave the environment. Okay, so questions from the audience. And there's no microphone, so if anybody likes to ask a question, please stand up and I'll repeat that. You want me to go back to the process?
Well, I just want to understand at a functional level, does that mean that there's like a bottleneck with everybody that needs to, a team that needs to manually review every single pull request coming in, or how does that actually play out in real life?
Okay, so I'll repeat the question. The question was whether the pull requests need to be manually reviewed or there's an automatic process. So it depends on your branch protection rules. You can do either or. The checks APIs can return a fail or success status, but you can override that manually if you're the admin of the repo. So you don't have to accept the results. We recommend that you, if something has failed, at least manually review what happened before and don't automatically approve it. But there's always exceptions, so you can do that. Thank you. Okay, very good question. The question was, where do we get the list of vulnerabilities and how agile is it? So actually, one of these ingredients that are required is to get the comprehensive list of vulnerabilities from multiple different sources. It's not enough just to tap into NVD and get the known CVEs, because not everything is out there. There's language-specific security advisories. There's security issues open in public repositories, like even GitHub, in public trouble ticketing systems, like in Jira, and there's multiple different other sources. We in WhiteSource support more than a dozen of these sources, and we maintain a research team that actually curates them, but everything is pretty much automatic. But you have to be on top of that and do that continuously all the time to make sure that you're on top of every security vulnerability that comes up, and not just in NVD. Thank you. Sorry. Yeah. Sure. Okay. Great question, and definitely comes up a lot. The question was, how long does a scan take? And if it takes a day, how can I actually use it? So scans have to be performed in the boundaries of the build time. And build time couldn't take a day or even an hour usually. It needs to happen within very few minutes or even less than 1 minute. Modern security times on open source components rely on hashes. So you don't have to statically scan the full lines of code. You're based on some kind of digital hashes, and you compare these hashes with known security vulnerabilities. So it's kind of seamlessly integrated. It's definitely running within the boundaries of a build, and any other solution that will run longer, it's just not acceptable in modern time where CI/CD is continuous and there's multiple different builds a day. Thank you. Questions? Any more questions? Okay, thank you so much.